Okay, moving on to example 4, we have evaluate secant squared of tangent of x, secant squared of x dx. So a couple things going on here. I got secant squared of x, I got a secant squared of tangent of x. And we have to consider specifically which function is more important. Okay, and first off, let me just clarify that there's two functions happening here. I got secant squared of tangent of x, that's one function. And I got secant squared of x, that's a second function. Alright? Now, there's no mathematical rule that says this, but this is the thing I do. Whichever one looks more unfriendly, that's probably the one I want to work with. Typically. That's how it works. So looking at the two, secant squared of tangent of x, secant squared of x, which one's less friendly?
Tangent of x.
The secant squared of tangent of x, right? The blue one. Alright? So the more unfriendly one is this one, and the type of function it is a secant squared function. Which again, if I'm dealing with trigonometric integrals, I got 6 that I'm looking for. I'm looking for sine, cosine, secant squared, cosecant squared, secant tangent, cosecant cotangent. Secant squared is one of the ones I like, right? So that's a good one to go with. So I'm going to say secant squared is the type of function. I don't care about this secant squared. All I'm worried about is this one. Once I've made my decision that I'm going to focus on this, everything else is not even important to me. My basic vision right now looks like this. I don't care about anything but that. Once I've made that decision that that's what's important to me, the rest of the problem is invisible to me for right now. You have to train yourself to do that, so I'll put it back up there. But yeah, that doesn't exist right now. It's invisible. All right. So it's a secant squared function. Second thing we have to worry about is what is the argument of that function. So what is the argument of the secant squared that we're concerned with? Tangent of x. So tangent of x is the argument, and again, I'm going to let u equal that argument. U is equal to tangent of x. What type of function? What is the argument? Call u that argument. All right? If u is equal to tangent of x, and I want to do the differential of u, it's going to be du is equal to what? What's the derivative of tangent of x? Secant squared of x, right? And then we're doing differential, so that's going to be dx, right? Now this is like the wonderful stuff that happens sometimes when you're doing all this ignoring of things. All right? I was focusing on this, I was ignoring that. That didn't exist because I couldn't see it. My eyes just blurted out. Okay? I did this, and notice secant squared of x, dx shows up, and this little faint memory, wasn't there something in this problem kind of looked like that? Oh yeah, there was, and then all of a sudden it just like shows up in my face again. So secant squared of x dx is du, that's secant squared of u, so notice we get secant squared of u du constructed out of the original problem. Taking a very complicated looking problem and changing it into a very basic problem. Change tangent of x into u, change secant squared of x dx into du. And now I'm just integrating secant squared of u. Antiderivative of secant squared is tangent. Didn't even have to modify the problem at all, right? It was already constructed properly. So tangent of u plus c, and then again, once I get tangent of u plus c, tangent of x plus c. Change u back to what it is. So the original problem was tangent of x plus constant. Okay, so far every problem has been in indefinite integral. I'm pretty sure that's how I made your homework. If for some reason it's a definite integral, the only extra step, I'd leave the plus c off and just substitute the x in and evaluate. So top one evaluate, bottom one evaluate, then subtract. If that should happen. But there's another way to handle that too, which we're going to look at tomorrow. But for right now, that will be sufficient. The way we do it tomorrow, you might like better, you might not. So just go ahead. If there's any definite integrals in the homework, just going to handle them like normal. And we'll look at a different technique tomorrow that you may prefer, you may not.